on 6PR, this is Perth Overnight with John Lewis.
As we look up into the sky at 9 minutes to 3, what do you see? Well, if you've got some good binoculars or a pretty good or a half-decent telescope, you will see 2012 DA14, a 200,000-ton asteroid. Where do you look for it? Well, let's find out as we talk to the Director of Astronomy Education Services, Richard Tonello. Good morning, Richard.
Good morning. How are you today?
Well, I'm excited. Not often you get to see something this big come flying by. Have you seen it yet?
Yes, we're actually tracking it right now. We've visually acquired it at 1:30 this morning, and we've locked onto it, and as we speak, I'm manually guiding on it now. So it's zipping across the field of view at quite a rate of knots. And I have to keep making corrections every few seconds just to bring it back into the field of view, because otherwise it disappears, because it's moving that fast. And it's accelerating too.
Why would it be accelerating? What's making that happen?
Because it's getting closer to the Earth, and as it's getting closer to the Earth, so the apparent motion is actually, looks like it's getting faster. And also a bit of gravity is playing its part as well, so that's speeding it up a bit too. But as it's getting closer to us, it looks like it's going faster.
It seems pretty big to me, 200,000 tons. How is that in the scheme of things with asteroids?
Small. It's only something about 45 metres across and 190,000 metric tons. But still, if this thing was to make Earthfall, it would hit with a 3-megaton nuclear blast,
yes,
or similar to. So it's something that shouldn't be sneezed at, but by all means, it's not the biggest. The one that actually wiped out the dinosaurs some 65 million years ago was about the same size as Mount Everest. So that just gives you a basic comparison. We're talking a small 45-metre chunk of rock as compared to Mount Everest.
Yes. I could visualise the difference that would make. What do we learn from 2012 DA14?
We learn, for a start, we shouldn't take things for granted as far as, what is up in close Earth orbit or near Earth orbit, such as these rocks. We need to be literally patrolling the skies quite a lot just to find these possible impact hazards, because if we don't, and suddenly there's one upon us, well, it could mean the extinction event or localized damage. So it's good to know these things so we can have, forewarning to either A, do something about it, or B, evacuate people from that area where we approximate it's going to hit and save a lot of lives.
We know our optical devices are always going to be limited when we're looking for these things. What's the best way to literally scan the skies?
The best way to scan the skies is to get more funding from the government. That's it, more funding. No bucks, no Buck Rogers. Simple as that.
All right, well, we'll put that on our wish list. Right now, though, Richard, where do we find the incredible asteroid as it makes its way? You
have to literally look straight above you. My telescope is currently pointing straight up, so just scan the skies up there. It is reasonably bright, so a decent pair of binoculars aimed straight up. Just be patient. You should see a small star moving across the field of view, and that is DA14.
Not easy to confuse with anything else up there?
No, not at all. Because you'll see the star moving across, and that is it.
And with some good power, what do we make of it? Is there a tail on this thing? Forgive my ignorance.
No. Comets usually produce tails because they're made of ice and dirt. They're just big, dirty snowballs. And, of course, they go around the sun and they start to melt, like an ice cube going around in a source of heat. But asteroids are made of either rock or iron or nickel or a conglomerate of both. So this particular one here, I'm not exactly sure what its composition is. I think it's more a rock rather than a lump of iron or nickel. But this won't produce a tail. It's getting nowhere near the sun, so there's nothing for it to melt off. So we just see the light reflected off it by the sun as it zips its way past our planet.
And it's passing by some satellites inside the trajectory of some of our satellites. No chance it's going to connect, is there?
No, well, I'm hoping quietly that it will click one or, cause one to blow up, because that'll look awesome on the video feed right now, but nothing's gone bang yet, and I'm hoping something will happen.
Oh, Richard, you've got your fingers unofficially crossed. All right, well, we'll think about that one. And I can't get out there to see it. I'm here working. When's my next opportunity?
Anytime you want. Not so much to see DA14, or we can actually see the streaming footage now. You can get onto NASA TV, and we are currently broadcasting live on NASA TV as we speak. If you miss it, like you're sensibly tucked away in bed asleep, then you can always watch the replay anytime you want. You can download it and watch this little dot go streaking across the night sky.
Incredible. I know you're doing a lot of work for NASA as well. What's their main interest in this? Is it merely just to know where it is for next time?
Yes, it is. NASA JPL, NASA Jet Propulsion Laboratory, and also the Minor Planet Center in Massachusetts keep close eyes on the near-Earth objects.
Yes.
And it's just like a good idea to keep a track on these things.
Sure. Are we talking about 100 years or so before it comes back again?
No, it's got roughly the same orbital period as the Earth, but I think it's slightly less, but don't quote me on that. But this just happened to be the right epoch where our paths have crossed and we've met at a fairly close approach. But its orbital period is only like about 300-odd days or something to that effect.
Wow.
But yeah, so it's something that we can see probably again, but not this close.
All right, and just put my mind at ease, I don't have to worry about it because, I don't know, Richard, no. 200,000 tons of asteroid.
Look, it's not going to hit us. NASA and the guys at the NPC have done a lot of studies on these things, as well as, astronomers around the world have kept an eye on this thing, and it's not going to hit us. And I can't see any big flaming, torch of death coming from the heavens at the moment, so good. I think we're okay.
All right, so race out with my binoculars or any kind of telescope I can get my hands on, point it pretty much straight up, and if I'm patient, I'll see something that looks like a star moving across quite quickly.
A moving star. Yep, a moving faint to medium star.
These are special times. Richard, I know you're crazy busy there, so I'll let you get right back to work. We appreciate your time.
You're welcome. No worries. Have a good night.
All the best. Richard Tonello, he's out there as we speak, staring at the heavens and having a good look at 2012 DA14. If you miss it, you can go check out NASA TV. In fact, you can go there now and see it live online.